Let's take a look at exercise 3.2, number 7. We want to graph the equation 3x plus y equals 6 by plotting point. Okay, so let's go to our paper. This is my equivalent of a piece of paper. And we want to graph this equation by plotting points. The thing to understand is that an equation of a line, when you go to graph that, is determined when you graph 2 points. If you try to graph any points other than after those first 2 points, the line has already been determined, and they're just, if you haven't made an error, they're just going to lie on that line. So all lines are determined by 2 points. Any additional points don't give you any new information. All right, so I am free to choose the x's or the y's that I want to choose. One of the things I want to do in my choice is I want to avoid fractions. So I want to make choices that of course I'm not going to choose a fraction, but when I choose a value, I want to make, say for instance I choose an x value, I want to make sure that doesn't cause my y to become a fraction. Or if I choose y, I want to make a choice so that my x doesn't become a fraction. In this particular case, and in many cases, but not in all, an easy choice is to choose x equal to 0. Sometimes that, in other words, a choice is a great choice if it avoids fractions and keeps you on your graph. Those are the two things you have to keep in mind. If a choice causes the other coordinate to become a fraction, or it takes you off of the graph that you're trying to plot the graph on, the line on, then you haven't made an appropriate choice. You need to choose again. So I'm going to choose x equal to 0, and I'm going to put that value, and notice I have a lot of freedom here. And those are pretty much my restrictions. I want to avoid fractions, and I want to make sure my choices keep me on the graph. Other than that, you have freedom. So you don't have absolute freedom, but you have some freedom. So I chose x equals 0 because it is simple to work with. It avoids a fraction value of y, and it will keep me on the graph that I need to plot this line on. So 3 times 0 plus y equals 6. Since 3 times 0 is 0, that gives me 0 plus y equals 6, which gives me y equal to 6. Now I'm going to make another simple choice, and that is I'm going to let y equal to 0. And what are my two issues that I have to be concerned with? I have to make sure that my choice doesn't cause the other variable to become a fraction, and that that choice keeps me on the graph. And you'll see the more you do this, the more comfortable you'll feel doing it, and the more quickly you'll be able to do it. So when y is 0, I wind up with 3x plus 0 equals 6, which is simply 3x equals 6. When I divide both sides of this by 3, I then get that x is 2. When you are graphing a line by plotting points, you only need 2 points. And so notice that I'm going to plot the point 0, 6. So when x was 0, y resulted in the value of 6. And when y was 0, the result for x was 2. So I'm also plotting the point 2, 0. Now, a lot of times, 3 points will be used. Remember that all that third point does is check. It's a checkpoint. It helps you to make sure you haven't made an error, because it's very difficult to make a mistake and get 3 points on the same line unless you have consistently made the same mistake, which most people aren't consistent in their errors. All right, so if this is what I need it to be, and I know I haven't made a mistake, but if you wanted to check yourself, you could pick another value for either x or y and get the corresponding coordinate that goes with that choice. However, it's not necessary. And you will see this when we go to work this problem. So when we go to work this problem, notice that when I open the graph, I'm going to make it bigger. I'll say medium. I choose the line tool, and then I'm going to plot my 2 points. So remember, when x was 0, y was 6. Notice that's a y-intercept. So I have 1 point on the graph. When y was 0, x was 2. That's my second point on the graph. The line is determined when you plot 2 points. If you had a third point, you would only be using that to make sure it actually lied on this line. Say, for instance, if x were 1, I would have 3 plus y equals 6, and that would mean y would have to be 3. So when x is 1, y would have to be 3. And notice I see that that's actually a point on my line. So, but notice the line is already determined. If that third point didn't lie on my line, I would go and check my work. But the line has been determined when I plot 2 points. So this is my line. Notice it's downward as I move from left to right. So if I'm on the line and I move to the right, I have to go down to get back on that line. So this means the slope is negative. So it's a downhill line and has a negative slope, which we haven't really talked about slope yet, but we will. Okay, so this is my line. I'm going to save it. I'm going to check my answer, and I did well.